All right, buckle up, everybody, because today we're diving into a topic that's really stirring things up in the science world.
Oh, yeah, it's a big one for sure.
We're talking about a debate that's questioning some pretty fundamental stuff about viruses, like how we even study them.
It all started with this blog post, from Meducate. The title is kind of a mouthful. The financial and scientific implications of rethinking virus theory.
Yeah, no kidding. So what's got everyone so riled up about this? What's the big deal here?
Well, the thing is, this debate has huge implications. It goes way beyond the lab. We could be talking about big changes in medicine, in the economy, even in how much we trust the whole scientific process.
Whoa, okay, so maybe we should back up a sec then. For anyone who needs a refresher, what exactly are viruses anyway?
Okay, so imagine a virus like a tiny little package. Inside, you've got some genetic material, could be DNA or RNA, and that's all wrapped up in a protein code. Now, here's the thing. Viruses can't make copies of themselves on their own. They need to invade a cell, a host cell, and basically hijack its machinery to reproduce.
Kind of like a tiny little pirate taking over a ship.
Yeah, a perfect analogy. So to study these pirates, scientists, what they do is they grow them in these things called cell cultures, basically like dishes of cells that the virus can infect.
Right, like a playground for viruses.
Yeah, exactly. And then they watch how the virus messes with the cells, looking for specific changes that tell them, yep, that's a virus at work.
Okay, so far so good. But this is where things start to get a little controversial.
Right. Enter D. Alex Zeck. He's been making waves with this pretty bold critique.
Fill us in. What's he saying?
Well, Zeck's argument is basically that the way we isolate viruses isn't pure enough.
What does he mean, pure?
So he says that for true virus isolation, you should only use stuff that's naturally found inside the host. But the way we do it now, we often add things like, antibiotics.
To stop bacteria from contaminating the sample.
Right, exactly. But Zeck's concern is that by adding those extra things, we're kind of muddying the waters. Maybe those additions are affecting the results.
So we might not be seeing the true pure effect of the virus itself.
That's his point. Zeck's saying, hey, maybe those extra substances are creating a situation where you've got multiple variables at play, and then it becomes a lot harder to say for sure what the virus is doing all on its own.
That's a really interesting point. So is anyone pushing back against this?
Oh, yeah, for sure. In fact, you won't believe who jumped into this debate. Meta AI.
Wait, hold on. Artificial intelligence is getting involved in virus research now. Okay, this is getting good.
I know, right? It's pretty wild. And what Meta AI said was basically, look, manipulating the conditions, like adding antibiotics, that's standard practice in science. The whole point is to control variables so you can isolate the effects of the virus.
Okay, so we've got Zeck calling for this super pure isolation, and the AI defending the standard methods of controlling variables. Sounds like we've got a real clash of ideas here. So where do we go from here? What are the next steps in this debate?
Well, I think the big question that comes out of all this is, what even counts as a truly independent variable in virus research? If we can't agree on that, then what does it mean for how we understand viruses in general? It's a pretty fundamental issue.
Yeah, no kidding. This is where I start to get a little nervous, because if we're questioning something so basic, so fundamental to how we study viruses, what kind of impact could that have on everything else? I mean, this could have some pretty far-reaching consequences, right?
Absolutely. And the blog post dives right into some of those potential consequences, especially when it comes to, money, like serious money. Zeck actually estimates potential losses of $50 to $100 billion for the pharmaceutical industry. 50 to 100 billion, that's a lot of zeros.
Whoa. Yeah, no kidding. And why so much? What's the connection there?
Think about it. Vaccines, antivirals, all these medications we use to fight viruses. If Zeck's critique gets traction, the effectiveness of all those treatments could be called into question.
Oh, wow. Yeah, I see what you mean. So the impact wouldn't just be limited to the pharmaceutical industry, would it? What about healthcare systems? How would all this affect them?
It would be a huge ripple effect. If we suddenly have to rethink how we understand viruses, healthcare systems all over the world would be scrambling to adjust. We could be talking about changing treatment plans, reevaluating vaccine schedules, figuring out how to allocate resources in this whole new landscape.
It's like pulling a thread on a sweater and watching the whole thing unravel. I mean, even thinking about it makes me a little uneasy, And on top of all that, there's the question of public trust. What happens to people's faith in science when something like this comes up?
That's a really important point, and the blog post touches on this too. Imagine you're someone who really values knowledge. You want to make decisions based on evidence. You trust science to guide you.
Yeah, I think a lot of our listeners are like that.
Totally. So when you hear that the way we've been studying viruses for decades might be flawed, it's only natural to feel a little shaken up, maybe even a bit betrayed.
Like everything you thought you knew is suddenly up in the air. And it's not just about viruses, right? This whole thing makes you question the entire scientific method itself.
Exactly. It forces us to confront this tension between, on the one hand, wanting to study something in its purest form, and on the other hand, needing to control variables in the lab to get reliable results. It's a philosophical puzzle with some very real-world consequences.
Absolutely. So let's talk about those consequences a bit more. The blog post brings up vaccine skepticism as a case study, kind of to show how this debate could play out in the real world and what kind of economic impact it could have. What can you tell us about that?
Sure. So the Post cites this CDC study that found routine vaccinations in the U.S. have saved over 1 million lives in the past 3 decades.
Wow, 1 million lives.
And not only that, but it's also saved something like $540 billion in healthcare costs. That's a pretty powerful testament to how effective vaccines are and huge economic benefits they bring.
It makes you wonder, what would the cost be if we didn't engage in this debate? If we just ignored it and maybe ended up undermining trust in vaccines even more?
That's a crucial question to ask. But while the financial implications are huge, I think we have to be careful not to focus on the money too much. It's easy to get caught up in the doom and gloom scenarios, but this debate could also lead to some really positive changes.
How so? What kind of positive changes are we talking about?
Well, for one thing, Zeck's critique could push scientists to develop even better research methods. Maybe it'll lead to new breakthroughs, who knows? And it could even force us to take a hard look at how we price pharmaceuticals, how research funding is allocated, all sorts of things. There's a lot of potential here.
That's a really good point. It's easy to get bogged down in the negatives, but this could be a real opportunity for growth and progress in scientific community. So where does this leave us right now? What's the takeaway message for our listeners?
I think the most important thing to remember is that this is just the beginning of a much larger conversation. Science is always evolving, right? New questions come up, research gets refined, and sometimes even controversy can push us toward a better understanding of the world.
So it's not about throwing everything we know out the window. It's about recognizing that our knowledge is always expanding and being open to questioning even the things we think we know for sure.
Exactly. It's about embracing that healthy skepticism and always being willing to learn more.
And that's where you, our listener, come in. We want to hear your thoughts on all this. What questions does this raise for you? What are your concerns? How do you see this debate playing out?
We always love hearing from our listeners, so don't be shy about sharing your perspective.
And who knows? Maybe your questions will inspire the next big breakthrough in virology.
So as we wrap up, we want to leave you with a question to ponder. If our understanding of something as fundamental as viruses can be challenged and refined, what other areas of knowledge might we need to re-examine?
What assumptions are we holding on to that might need a fresh perspective? What so-called settled science might be due for a shakeup? These are the questions we should all be asking ourselves.
Don't be afraid to challenge the status quo,
Yeah.
to question what you think you know. That's how we keep learning and growing.
And that's what the deep dive is all about. So until next time, keep those brains buzzing, keep asking those tough questions, and never stop exploring.
And stay curious, everybody. We'll catch you on the next deep dive.